Hi everyone, welcome back to another Algebra 1 tutorial. In this video, we'll be going over solving more inequalities. So the first inequality we'll be going over is compound inequalities. So compound inequalities are a combination of and or inequalities. So when graphed, compound inequalities can either be a line with two dots on both sides or two different lines with arrows facing either direction. To visualize, let's look at an example. So suppose we're given an inequality as such. So all numbers less than 7 and greater than 5. And we're told to graph this. So to graph this, we would graph it like so. So 0 would be somewhere here. 5 would be here. Let's just say 7 would be here. We draw an open dot since there's no equal to here on both sides. And then we'll draw a line connecting them. And this would be a graph. So, or we could just only draw this portion and that would still be a graph, which should hold true for this inequality. So now let's solve a few compound inequalities. So suppose we're given an inequality as such. 3 is less than x plus 5 is less than 9. And we're told to graph for x. First thing we would want to do is separate the inequality into two different inequalities. So now we have x plus 5 is greater than 3 and x plus 5 is less than 9. Here we could subtract 5 on both sides to get x is greater than -2 and x is less than 4. And we're told to graph, we would write -2 over here, 4 over here, two open dots, and a line connecting the two. So now let's go over the intersection of inequalities. Suppose we're given two different inequalities. X is greater than 15 or 1 and x is less than 9. So we're given the inequality x is greater than 1 and x is less than y. So to find the intersection of these two inequalities, we first need to graph them. So we have two graphs. And we have, let's say, 1 over here and 9 over here. So what we do is first we'd graph these inequalities. So one inequality like so, and one inequality like so. Now, the intersection of these two inequalities is where these two dotted lines are. So now we have one circle which would go over here and one circle which would go over here. So now if we look at this graph again, we would get something like this, where this would be 1 and this would be 9. And we could rewrite these two as x, and we could write in between 1 9. And this would be, and this basically is these two inequalities combined with each other. And the intersection of inequalities is also the solution of two or more inequalities. Absolute value inequality. So similar to compound inequalities, absolute value inequalities also require an extra step to solve. So, as the name suggests, an absolute value inequality is the inequality of a variable inside an absolute value, such as the absolute value of x is greater than 5, or the absolute value of y is less than or equal to 6. So both of these are considered as absolute values, And if we're told to solve one of these, let's take this one for example. Our first step would be separating this into two different inequalities. So now if you visualize this problem in a graph, in a number line that is, where this is 0, so the absolute value of a number is the distance of that number from the center, which is 0. So if we would want to graph this, the first step would be making this into two different inequalities like we did with the compound one. So what this suggests is that the distance of x from 0 has to be greater than 5. So the distance of x from 0 has to be greater than 5. So no matter where x is in the number line, the distance of it has to be greater than 0. So if we take 5, then the absolute value of 5 is equal to 5. However, 5 is not greater than 5. Thus, 5 would not work. Thus, we will not do a closed dot, especially since this is not an equal to. Instead, since if you want to get a value greater than 5, as the absolute value of that value needs to be greater than 5, then it needs to be greater than the actual digit 5. So we draw an open dot over here, and we draw a line going to the greater than sign. Similarly, we have negative 5. Negative 5 is the absolute value of negative 5 is equal to 5, and I said before that 5 is not greater than 5. Thus we draw another line here and we make it go less than. Since if we took something else such as negative 2 or negative 4, the absolute value of negative 4 is 4, and 4 is not greater than 5. So it has to be less than negative 5. For example, negative 6, an absolute value of 6, and 6 is greater than 5. So if we cleared out all of that and looked at the graph, we would see that the graph actually has two different lines facing in opposite directions. So this would be our solution graph. Okay, so now let's do a few sample problems to help us more with this concept. So we're given an absolute value inequality. The absolute value of 5x plus 6 is less than 16. So to solve this, we'd have to make two different inequalities. So 5x plus 6 is, so here we need to find the symbol. So 5x plus 6, we need to fill in the blanks. So 5x plus 6 blank 16, and 5x plus 6 blank negative 16. So if you look at it in a graph, it's basically saying that the absolute value of 5x plus 6 needs to be less than 16. So the distance of this whole equation from 0 needs to be less than 16. So thus, if we looked at it like that, then we could just take away the absolute value sign to get 5x plus 6 is less than 16. Similarly for this one, it needs to be greater than negative 16. Since if this is equal to negative 17 or so on, it would be the absolute value of negative 17 less than 16, and the answer would be no, since 17 is not less than 16. So now we have two different inequalities. So 5x plus 6 is less than 16, and 5x plus 6 is greater than negative 16. So So to solve this, we need to subtract 6 on both sides on the first expression to get the first inequality to get 5x is less than 10, which can be simplified to x is less than 2. So this would be one of our solution, the part of our solution. Now we need to subtract 6 like we did for the first one to get 5x is greater than negative 22. And if we divide 5 on both sides, we'd get that x is less than negative 4, 2 by 5, which is basically negative 4.4. So now that we have two inequalities, x less than 2 and x greater than 4.4, in a number line it would look negative 4.4, 2 over here, negative 4.4 over here, an open dot, then another open dot, and a line connecting them. So we also have another one, 4 plus 2x is less than 3x, which is less than 18. So this is a compound inequality. So as we did before, we need to separate it into two different inequalities. So 3x greater than 2x plus 4 and 3x less than 18. So we would first have to subtract 2 from both sides to get 3x minus 2x, which is x is greater than 4. And similarly for this one, divide both sides by 3 to get x is less than 6. And then in a graph, it would look like so. And this would be the solution to our inequality. Thanks for watching. Make sure to like and subscribe if it helped.